Thanks again, everyone, for coming. I know there's lots of other places that you could be, lots of other webinars to attend. So really excited to have you all here. I'm Aaron, founder and CEO of Promotable. Before we get started, I hand it off to Dave. Just a couple of quick announcements, and then we'll get going. So Promotable, what are we? So we are a workforce accelerator focusing on closing data skill gaps. And so we do that through a couple of ways. One is weekly events just like this one. So we bring practitioners from top companies who do this every single day to answer your questions, learn something new, and hopefully help everyone make data-driven decisions and cut through all the buzzwords around data. In addition to that, for anyone who wants to dive deeper into data, we also have live online courses. Those are all taught by instructors who are just like our speakers, all practitioners from companies like Nielsen or Discover or Abbott, Groupon, Grubhub. We've had them from almost everywhere in Chicago here, but all people who really good at what they do and are excited to help you take your career to the next level. And so that's a 5-hour-a-week class. You learn things like SQL, Tableau, and then you walk away with a work product that you can show a recruiter or your boss. And that's designed for folks who are, we'll say, data newbies. You might know some Excel, but you want to either get out of Excel or learn to use the visualization or what have you. So anyone who's interested in that, feel free to send us a note. Go to aaron@promotable.io. Of course, feel free to go to our website, promotable.io. With that, for everyone who likes these events, we want to keep them free. Please like us on LinkedIn, on YouTube, on Twitter. Really appreciate it. We're still a small startup, so every little bit helps. I know you hear that a lot, but in this case, it really does matter. So with that, I'm going to hand it off to Dave. He'll give his talk. Please ask your questions in the comments. We'll either address them as they come in, and then for those a little bit longer, we'll wait until the end. And with that, Dave, handing it off to you. It looks like a really, really exciting deck.
Thank you, Aaron, and I appreciate everybody who's here. I'm going to actually leave this in non-presentation mode and hope everybody can see it, because this way I can see the chat window easier. Again, my name is Dave Cameron. I'm the Vice President of Data Science at a company called Navistone. Prior to that, I spent 12 years in various senior roles at the Nielsen company, and 5 years before that at Merkle, one of the top database marketing companies in the world. So what I want to talk about is an application of data science in today's world and give you a sense for what businesses are funding and what's valuable to people. And so it's all around targeting mobile coupons for consumer packaged goods. So the objective is, we have a retailer. It's a grocery retailer. It's like a Safeway or a Kroger or a Jewel or what have you, that sells in store, but people will download an app and they'll have like the grocery retailer's app, and the grocery retailer will send them coupons. And through that app, they have to decide what's the right coupon to send to the right person and base it off of some smart knowledge that a data scientist can put together. And we wanted to do a few things. First of all, I don't know if everybody knows who Nielsen is, but one goal of Nielsen is they work with the packaged goods industry and have these retailers like a Jewel or a Walmart or a Kroger or a Safeway, but all the manufacturers like Procter & Gamble or Coca-Cola or people who would put stuff in a grocery store. And so we as a business wanted to prove out Nielsen's value, but we also wanted to make value for the retailers, value for the manufacturers, value for the consumer, have everything going on. And with the whole move to mobile these days, I mean, this was even pre-COVID, and people were buying and shopping online through mobile, but also going in the store and wanting to redeem these coupons. So how do we do that? Well, the current environment is, a lot of people still get paper coupons or what have you, where you get the Sunday paper and you clip stuff out, or you go online, and the second one is online. You look at all these price promotions and say, oh my. So then you have mass communication. And the picture, if you can see it, is intended to show an older couple in their 50s who are getting ads for Pampers or Cocoa Puffs. That, yeah, it's great when you're 30 years old and you have little kids at home, but not when you're 50 and whatever they're buying in their baskets. And there's just so much stuff out there that go unnoticed and aren't relevant to people. So we move into something called personalization. Personalization is targeting the coupons to you. It could be one-to-one marketing. It's commonly used to enhance customer service or e-commerce sales. In Amazon, you look at a quote from Jeff Bezos who says, if we want 20 million customers, we need 20 million stores. So when you go into Amazon, you get something called collaborative filtering. You get stuff that's tailored toward you. Or the LinkedIn CEO, same sort of thing. You want relevancy to your profile. And so personalization can increase you as a consumer engaging with this retailer. It can increase satisfaction. It can increase loyalty, and everybody's better off. So in the data science world, we see that coupons and circulars are transitioning from print to mobile. Even the online stuff is out of date. And personalization provides the most relevant promotions to the consumer. So when she's in the store, she sees, oh, I'm getting this stuffed Greek yogurt and Venus shaving stuff. I'm not a woman. I don't know what this is. Sorry. And predictive modeling will help pick what the right things to send are. What's relevant? What's going to sell that? And not only sell things that they wouldn't already buy. So let's think about it. Let's say you're Coca-Cola. And if I go into a store, I'm a Coke addict, I buy Coke every time I'm there. Well, I'd love it if you sent me a coupon, but that doesn't help Coke and it doesn't help the retailer because I'm going to buy it anyway. So why give me a discount? So it's all about incremental sales impact. You could reward me, sure, but you know. So there's two things. With the phone, you have to personalize the display. You have to show something to each owner of your iPhone or Android that says, Google Pixel, whatever, here's what I got. And targeted promotions means that then besides the display, what specifically am I going to target you between a cooperation between the retailer and the brand? Because you got three different players in mind here. You've got the consumer, but you also have, the retailer has to say, well, this helps me. And the brand has to say, okay, but this helps my brand too. So sometimes they got to work that out, right? So you've got Coke and you've got Pepsi competing for space within the Walmart Supercenter. And so Walmart has to say, this has to help me. Why should I pick Coke over Pepsi? And Coke has to say, well, it's got to help me. And Pepsi's got to say, well, I can't lose in this. Maybe they can, but it's got to be better for Walmart. So here's how it works. First, you have to have a shopper card in the first place. So we, as data scientists, come up with an algorithm, which I'll talk about, that calculates coupon scores and ranks. And so it scores everybody by coupon and ranks them from most likely to least likely. We then deliver those to the app, and we also have to deliver to the website too, so that when you go in, there's identity resolution, right? You go in and you log in through Google, but now let's say you don't have a Pixel phone, you have an iPhone. Well, okay, that's the problem. How do we know that you're the same person? So we have to deliver those coupons to you both on the app and the website and know that, hey, I'm Dave Cameron in both cases. The coupon is selected, it's saved to your card, and then when you swipe your loyalty card at the checkout, you automatically get the coupons redeemed. So it's all got to be integrated in this platform. But a big thing for data scientists are you need to have the right data. I don't know how many of you have heard the thing garbage in, garbage out. So if you don't have good data coming in, you're not going to have good results going out. So we had three sources, and I can say this, I haven't been at Nielsen for 3 years, but I was at the time we did this 4 years ago. And I can still be objective about it because I'm not there anymore. But in reality, the most important thing is the loyalty card data. What have you bought before? The second thing is the Nielsen home scan data. And the third thing is Nielsen demographics. And I'll go through these, but what it means is you have three separate models. You have a model built on prior purchase score. If you purchased this before, if you purchased this product group, if you purchased this brand. So let's play out the diapers example. I'm over 50. I'm not buying diapers. I'm not old enough for grandkids, but my kids are grown. So I haven't bought diapers in, I don't know, I'd have to think about it, 15 years. And so look at what I bought before. If I haven't bought it, don't send it to me. But there's also a product affinity score. What are correlations of stuff you've purchased to other things? And I'll talk about this too. And then a demographic lifestyle score. So there's three different approaches in here. and they're all independent from the sense of data. So you'd have an equation that would be predicting the probability you're going to buy this brand, that you're going to buy Coke, or you're going to buy Pampers, or you're going to buy DiGiorno pizza. And the prior purchase model looks at what you purchased in the past. Did you buy in this product group? If it's Coke, did you buy in carbonated beverages? If it's Pampers, did you buy in diapers? If it's DiGiorno, did you buy frozen pizza? That's the most important thing. Then the second thing is, did you buy that brand before? If I'm Pepsi loyal, I'm probably not going to buy Coke. But if I bought Coke before, it's more likely I'm going to buy it again. Recency, Microsoft does not like this as a word, but recency of product purchase. If you bought it more recently, you're more likely to buy it than if you bought it, like we with diapers. God forbid they had records from 15 years ago. But, if I haven't bought it recently, so why would I buy it now? And then frequently, the more often you buy it, and so on and so forth. And you have coefficients. We did a logistic regression for this. Oops, went too far. In order to build it, you have to compile the data. And we went to the retailer and they said, we can give you 5 million records. And it's like, oh God, I can't fit that on my PC. How about a 5% sample? And then did some exploratory data analysis, split it into a, what am I going to build the model off of or train the model off of versus what am I going to validate it on or test it on? So I built the response model on the 60% sample, what will they buy? And then I validated it on a 40% to see how well it worked. And you want to look at these predictors and see if they make sense. So one of them is denture adhesives. Denture adhesives, for those of you who don't know what dentures are, they're false teeth. So higher age was a big predictor. Makes sense. Negative predictors were presence of children. Well, that makes sense too. If you're old, you don't have children, at least not in the household. So you take a look at it, and you hear a lot today about machine learning, about AI, and I do machine learning models. But before that, where the data scientist comes into play is looking and saying, does this make sense? Give it the sanity check. The product affinity score, the next one is, what does it correlate with? So if you're selling Crest white strips, you run a correlation and say, for people who bought Crest white strips, what else is in their basket? And there's a bunch of stuff out here that's kind of, oh, Crest white strips, healthy. You want good looking teeth. So I've got, I don't know, kids Yoplait yogurt there. I've got Power Bar. I've got Crest toothpaste. Okay, I got Guinness. Well, okay, humor me. The other one would be demographic and lifestyle. So there's like 3 different areas. You could have younger kids if you're under 35 and you don't have kids, versus middle-aged without kids at home, people who aren't buying kids products, versus family life, people who are, and then mature years that's going to buy the denture adhesives or something. So when you build the predictive model, you need to look at who buys versus who's not going to buy, what responders look like, and contrast them what not responders look like. The other thing is you need to know what your model goal is. So many people will toss these in and not realize, yeah, but what's the metric? What's the measurement of success? Is it response rate? How many people responded? How many, clicked on the coupon? Or is it dollar amount? I mean, some people say, well, I don't care about how many people click on the coupon. It's how many dollars did they spend with us? A third one could be increased average monthly spend. This guy's got the app. He spends $50 a month with me. If I get him to 60, whoa, that's great. So you can't just go in and build a model without knowing what are you trying to optimize on and leverage that digital coupon platform. Before you even get there, sometimes you have to look at the app users themselves. I mean, my mother is 84 years old and she doesn't have a smartphone, so she's not going to use an app. And so when she goes into the store, all of this is irrelevant. But you can't blow them off. If you look at this, 43% of the app users are over 45 years of age. So the sweet spot is 26 to 35. These are people who have enough money. They go to the store regularly. They use the app a lot, but they're not the only ones. So you got to figure out, how do you weight that? App users are more likely to have children. Makes sense. Presence of children is a factor there, and that comes out a lot. And we found this through surveys at Nielsen. They're also more affluent. People who make less than $50,000 a year are less likely to have the app than those who make over 50,000 a year. And this actually made sense to us too, because a lot of times I'll play it out. I've got a 24-year-old daughter. She's got a phone that's old. It doesn't have a lot on it, doesn't have a lot of storage, because she's not going to shell out $1,000 for the latest iPhone when she's, not making that much money. So who are the best prospects for personalization? It's not enough to just have numbers to throw at somebody. You need to have a profile. You need to be able to go back to a manufacturer, go back to a retailer and say, here's what they look like. So sticking to my denture adhesives example, they buy single serve meals like the macaroni and cheese. They're 70 and older, so I got a picture of somebody who's older. They're 60% more likely to buy cat food than the average. And I kind of scratched my head on that one for a while. And then I thought about my mom again. She's 84 years old. She's got a cat. My dad's dead. Okay, that's her companion. Makes sense. So the key is to know who's buying. But if you're a data scientist, you got to tell a story from it. You got to be able to say, what do these people look like? So when you model and you score it, for each and every product, there's a separate equation. There's one for Coke. There's one for DiGiorno. There's one for Pampers. There's one for whatever. The higher the score, the more likely you are deem the coupon. And so then each card holder, each person who's downloaded this app gets a customer history score. They get that product affinity score. They get that demographic lifestyle score. And we weight them, we put them all together, and there's over 100 products and there's millions of customers, and lo and behold, we've got big data. But then what you can do is, as people go into the store, if they got location turned on, you can give them a coupon right there and then. It can be optimized for each person. This is wonderful. It's using modern technology to say, how do we make life better for the consumer? How do we make it better for the retailer? How do we make it better for the manufacturer? And we rank those coupons in order of preference, because you might have 50 coupons that are valid to you, but if you open that app, you're not going to scroll down to all 50. You better see the first couple and say, oh yeah, great, these are great for me. So what did we find? We found that total coupon redemption had a 13% increase. So if that was our target, and I said, what's the metric? If it's coupon redemption, great. We just got you 13% better than what you were doing before. If it's coupons redeemed for new products the consumer hasn't tried before with you, you get a 37% increase. And if it's coupons ranking in the top 10% versus the bottom percent, we saw a 7-fold number of redemptions that way. So by any metric that you can think of, and I didn't put dollars in here, but any metric you can think of, we got success. It's a plus for Nielsen. It's a plus for me leading the team that built this. It's a plus for the retailer, and it's a plus for the people, the manufacturer who's supplying. And that's really where data science works, is you get things that are going to work for everyone. And you don't have privacy issues. So many things you hear today about, Google's cutting off third-party cookies because, privacy concerns, and people are concerned about this kind of stuff. That's not an issue here. People downloaded the app. They downloaded the app, they've opted in, they want these coupons. The other thing is, I said there were 3 different scores. There was the purchase history, there was the product affinity, and there was the demographic and lifestyle data. So many people just do one by itself. It's like, why did Nielsen do this? I mean, Kroger has a team. If people know Kroger, they're the biggest grocery retailer in the US. Kroger has a team that does this, and they build it off of purchase history. Okay, that got you 2.7 times the lift. But if you add in product affinity, you get 1.9 times additional. If you add demographic and lifestyle, you get 1.4. So, I went to Kroger and I said, don't just look at your purchase history here. Look at your combined score. I can take your 2.7 and make it 3.8. So building in these different choices where you get each of the data sources, it goes back to what I said initially, garbage in, garbage out. But so much today is about linkage. It's about graph data sets. So it's no longer about going in and saying, oh, I've got a relational database where I look at purchase history and I've got all of these people and what they bought and, linked to each consumer cardholder number. That's great. That's a great starting point. But now in machine learning, there's edges. There's different graph databases out there where you say, oh, but I got product affinity, and that's a different set of tables that matches to different products that people purchase. I've got demographic lifestyle that comes from another provider, and how do I link all these together? And so part of this is the data engineering to link it all together and to provide the data scientists the way that they can run it through the latest machine learning models and make it readily accessible in a mobile atmosphere. And then you have to update. So in the old days, a statistician would build a logistic regression. They would put it out there, and then they'd say, great, it's built. I washed my hands of it. It's going fantastic. Yeah, that's not the way it works today. You get continual learning. You get new data in, the machine updates. Machine learning, you optimize your models as you go through. You analyze, you refine, you personalize. It's ongoing measurement to improve the personalization methods. I don't think you could turn this over to AI because you really need somebody to still look at this periodically and do that common sense thing. I found when looking at the data the first time through, I said, let me just look. I got that 5% sample. Let me look and see what's going on here. And I found that 0.2% of the people spent over $20,000 with this retailer each year, whereas everybody else spent under $3,000. So 99.8% spent under $3,000 with the retailer in a year. 0.2% spent over $20,000 with the retailer in a year. As a data scientist, I looked at that and said, that doesn't make sense to me. So I went back to the retailer and I asked them, and they said, oh, those are the cashier cards. You know, when you say, oh, I forgot my card, and the cashier says, no problem, I'll get mine out, I'll scan it. That's where those $20,000 plus came from. So I looked at it and said, great, I'm throwing those records out. I'm going to build the model off of what's left. If you just leave it to the machine and you don't look at that, those quote heavy spenders unquote are going to really skew the model toward people who spend a lot of money. But it's fake, it's bogus, it's not real. These are not real people, they're the cashiers. So cashiers are people, but the purchases are not from real people. So, you look at this and you say, I got a mystery to solve. I'm going to see what the culprit is, and I'm going to unmask the villain and find out that, oh boy, gee, Scoob, look what we found. It's actually the cashier. And we throw those records out and we move on. So that's my spiel in 20 minutes. I know I talk kind of fast, so I'm going to open it up at this point and leave it to Q&A.
Awesome. I think that was, one of the better talks we've actually had on kind of breaking down practical examples on data. I think a lot of people in the comments have agreed. Here we go. We've got a question from Marika, and I apologize if I butcher your name, so please forgive me. But she asked, are there grocery retailers specific apps or sites that coupons are run on, or are these third-party apps that Nielsen works with?
This was actually done through the grocery retailer app, and what Nielsen would be was we would be a data provider to that. So we had an API that enabled us to feed into the app our equations and our data and update in real time, but the actual app was owned by the grocery retailer.
Yeah, I agree. The Scooby-Doo reference was great. I was checking in the background, so I appreciate it. So here's a question. I know we have, while everyone else, guys, feel free to, ladies as well, please put more questions in there. In the meantime, I'll own the moderator's prerogative until folks ask some more questions. So I know right now, so you recently left Nielsen, now you're at a smaller startup, I think. Is there like a really big difference between kind of the bigger company versus where you're at now, or kind of tell us a little bit about that?
Sure. There's two different things. There's pros and cons. Let me put it that way. The great thing about being at Nielsen was I had a ton of funding to do this because Nielsen had deep pockets. We were a company that was 30 plus thousand people globally, and to be able to get the resources to build this out in an engineering platform and feed it into mobile apps was something that we had the money to do. A startup would have to the startup where I am now, it's not a startup, it's an early stage company, would find it hard to get the funding to do this because to do it would cost like 10% of our total revenues. So the pros were at a Nielsen, I could do this, I could get the data, I could do all that. The cons were that you needed to um, sometimes a bigger company moves more slowly, and taking in these innovative type of things looks at a situation and saying, okay, but where do I prioritize that in all of my offerings? A startup would say, hey, let's try it. Let's go in and let's do it right away. But it wouldn't have been as thorough because the startup wouldn't have as much money to be able to go in and do what you needed to do. So if you want to do something really fast and you want it to be kind of, 2/3 of the way there, an early stage company is a great place to go. If you want something that, well, I'm going to spend 6 weeks on this, and when I'm done, it's going to be phenomenal, then a larger company often helps.
Awesome. Here's another one, because I know a lot of our audience is typically folks who might not want to become data scientists necessarily, but I think everyone wants to level up on the data side. And I think just given kind of your breadth of experience and kind of senior leadership role, what would you say for someone who's like in marketing or product and they want to understand how data works, understand the importance of some of this stuff, but they're not going to go learn to code in Python. Is there something that they should be reading, or what's like the first thing they should probably learn or focus on?
Yeah, and there's resources out there that enable you to kind of get those basics. So one of the things I think about is, first, you need something around data modeling. And data modeling is actually how would you set up the data to get the answers you want? So if I think about this as a marketing manager and I want to know coupon redemption, but I also want to know how this worked relative to my competitors. So let me play out the DiGiorno pizza example. I buy from DiGiorno pizza, and now I'm looking at this and I'm saying, well, wait a minute, I'm in Chicago, so Home Run Inn Pizza is a competitor. I want to know how I'm doing versus them. Did I take market share, or did I grow the category? And so within that, you first need to have a way to just look into not necessarily becoming a database developer, but get the resources to search on data modeling. There's articles out there. There's classes like Probably Promotable and what have you. And similarly, if I were moving into data science and I wanted to understand enough about some of the machine learning algorithms, I'd want to get in and just understand, like, here, how they work. So logistic regression is what we use to predict this probability. You can find information about logistic regression, take a couple hours and learn about it and get the basics on it without having to go in and say, okay, great, I'm not going to become an expert. I'm not going to go in and download Python and play with it. But there are offerings that move you in that direction. Is that kind of what you're looking for, Aaron?
Yeah, absolutely. I've got one more question for you, but let me jump in here. I've got another question. Meher, I'm sorry, I just butchered his name. But he asked, going back to, I think you had a slide where you were scoring customers, I think based on the products that they might purchase. He was asking if you took a customer and scored them across a large product range, 100 products or whatever it was, and then ranked someone's ability to, or likelihood of purchasing products within that range. Is that correct?
Yeah, so Meyer, actually, people got 3 scores for each of the 100 products. So every consumer would have that downloaded the app would have a prior purchase score, a product affinity score, and a demographic and lifestyle score. And then there would be a weighting that would go along with those. And the idea behind that is the weighting could change over time, or the scores could change over time. It gives the data science the flexibility as new data comes in, as new purchases come in, to be able to take each one in isolation and move it.
And then Christopher just asked if you used tools like Python or R, or tools like Alteryx or RapidMiner to do data analysis. Never heard of RapidMiner.
Yeah, for stuff like this, I'm a big fan of Python, actually, but it's hard because tools move relatively quickly, right? There's a lot of things out there that that you can use. If I were presenting this to a client, I'd probably toss it into a data visualization tool like a Power BI or a Tableau. actually doing the analysis. The reason I like Python, and I can't believe I'm saying this, but the reason I like Python is because you can move it into a production environment very easily. So Christopher asked about R. I think you said R is probably a better language for pure out machine learning, statistical modeling, that sort of thing. But Python is more scalable to be able to turn over to the data engineering team to say, put this into production. And a lot of times they can take the prototyping code and just put it in as is with very minor modifications. So a lot of times in today's environment, if you go back 5 years ago, when a data scientist came out of school, they knew R, they could do a lot of fancy stuff. But now things have migrated to the point that you want to be able to say it's a seamless type of thing where the data engineer works closely with the data scientist, and everything you do, every prototype you do in research has to be put into an environment that can be applicable, that can make money right out of the starting gate. And, when I was coding 5 years ago, everybody was using Jupyter Notebook for Python, and now there's even a move away from that into scripting to say, yeah, but Jupyter Notebook's great for testing and playing in a sandbox, but it's not really great for production reproducible code.
Interesting. And for all the less technical folks who are watching, would you mind just going over the difference a little bit between what a data scientist does and what a data engineer might do?
Sure. A data engineer is concerned with the quality of the data, the pipelines as the data comes in, to say what's good and what's not good, and to be able to recognize that, oh, wait a minute, I was supposed to get real-time data from this grocery retailer, and I see 20,000 records a day coming in, and now all of a sudden it fell to 10,000. The data engineer should recognize that and set up the database environment such that everything flows and those pipelines come in and everything's updated on a regular basis, and understand enough about the domain to know that. The data scientist would then take it and do that outlier example I talked about to say, wait a minute, 0.2% of the records just look wrong. $20,000, that doesn't look right. So the data scientist picks up and then said, okay, the quantity of data is coming in right, and all the tables are populated, but the underlying data doesn't quite look correct, and I need to take it from that next step going forward. So what the data engineer would do is he would be an expert at a lot of the ETL tools, a lot of the bringing the data in, and know some Python. The data scientist would then take it more toward that analysis phase.
No, that makes sense. We've got a few folks who agreed on the Python thing that you mentioned. That's super interesting to me as well. Have you noticed that you use like different tools now at your current company that you're maybe didn't use at Nielsen, or kind of vice versa? I mean, I assume there's a cost issue, but if there's not a cost issue, is there a different reason?
Sure. I think some of it is just legacy environment type of stuff. So at Nielsen, they put a lot of effort into buying servers, back in the day where you would store all your databases internally, you'd have a client server type of thing, and had put a lot of money into ensuring it's there, it's secure. For the smaller companies, they've come of age recently and saying, well, yeah, but we'll just go to AWS for cloud-based, or we'll go to Microsoft Azure for cloud-based services. And that's been a shift in there. I think as we move more to open source, Power BI is now built into Microsoft Suite, and Tableau is great, but we're even seeing some things on people moving to open source visualization tools at the smaller company and paying for the licenses. So it's trade-offs. It's what you see in there, but I definitely see more of a move toward integrated open source type of things than, proprietary servers. And Aaron, if you go back, 10, 15 years, everybody was doing things on Sun Microsystems and client server type of stuff, right?
Yeah. And now those don't exist anymore. So it definitely changes quickly. So we're going to give everyone a few more minutes to kind of get their last questions in, and then while we're doing that, I'm going to throw a little more question your way. I'm just thinking for folks who are kind of, I know you touched upon this quite a bit, but thinking about, oh, here we go. Scott just asked a good question. What are some examples of open source database tools that are starting to become popular, or something that you use now?
Well, I know who Scott is, so I can kind of play to his geeky side a little bit. But if you are more into the hardcore data science side, Plotly is really good. Plotly was developed to interface with Python. It's an open source tool. It's taking the Python visualization above and beyond what they do right now. That's probably the biggest one I've seen. The ones that I've seen that are more open source that would be used more by marketers or by business people who aren't so far along, really pale in comparison to Tableau or Power BI. I've actually seen Power BI is taking over more and more market share, and Microsoft's big, they're pushing it and everything out there. And so they're making sure they try to keep up and keep the open source people, from cutting into their market share. So it's still really early in that stage.
Yeah, that's true. Yeah, that was my curiosity, because I assumed there had to be something for all the heavy Python users, but as like a person who was like formerly very not technical, always curious about like other tools for folks who are kind of like me, if you will. And kind of the last thing is just, I know a lot of times it sounds kind of like, it sounds like a dumb question, I think, for those of us who do this every day, but I also think it's important to ask, when you're thinking about, solving in this case, solving a business problem, thinking about how do I give the right coupon to the right person, how do you ask that question? How do you go back and kind of start that data initiative, if you will?
That's a great point, Aaron. And I kind of wish I thought of that when I started the slide, is because you want to get you want to get the stakeholders together, right? So in my mind, when you start an initiative like this, you need to have whoever the stakeholder is. In this case, it would have been like a VP of marketing, to say, what are your needs? What are we trying to get at? But you also want to have like the data engineers in the room to say what's possible, right? So when I said they said they're going to give me every cardholder data for the last 2 years. It's like they got 5 million cardholders and people go to a grocery store twice a week. I can't store all that data. I can't do all what, maybe I could today, but I couldn't 5 years ago when we did this. But I still need to find a way to get enough data and enough metrics. Like I was talking about understanding those metrics. Is it coupon redemption, or is it dollars, or is it incremental monthly? That all came from the stakeholder. So you need to have a stakeholder meeting. And you also need to realize it's iterative, because as a data scientist, I might not understand, like you said, I might not understand everything to ask the right questions. And then I get into the data and I go back like with the cashier card thing and say, something looks weird. So you're going to have back and forth as you go through that. And so from my perspective, you need to start with the stakeholder, the owner, but you also need to have the person who's going to run this. The marketing manager is going to be in the day-to-day. You need to have the data engineers. It's really great to have a cross-functional effort where you get everybody together.
Yeah, absolutely. Have you ever had a case where maybe you've gone to that stakeholder, said, here are the KPIs I'm looking for, and then maybe you've asked them, but why are you doing this? And then everything changes?
Oh, yeah. And one of the things in today's environment is sometimes it just changes because of technology or things that happen out there. I mean, just in today's environment, I had built a separate topic. I had built a model for a company that does consignment, and it's an estate planning company. So somebody dies and you go into the house and you say, oh, I got all this stuff and I want to, like Antiques Roadshow, I want to evaluate and sell it and what have you. Okay, COVID just changed that. Now you don't have somebody going into the house. So now you have to scan all the stuff in, you have to look at it. The business model has changed. And so the model has to pivot with that and recognize your inputs are not good anymore. And so what I did just got thrown out and spent a month to rebuild.
Yeah, I hear that. Well, last question we're going to take from Cheryl here. She asked about Seaborn. I think this is going back to our conversation about open source data viz.
Yeah, that's a good one from Python as well. I've used Seaborn as well. I probably should have thrown it out. I just took Plotly because I think it's a little bit better, but I don't want to be a shill for Plotly either. I'm just tossing out what's out there.
Well, we can say that none of these products are paying us. Although if they wanted to pay me, I would not complain. So we'll leave it at that. Thanks so much for taking the time. I think we've had some really good feedback, and people really enjoyed it. I know I certainly did. We learned a lot. So for everyone who's watching, please, if you're on LinkedIn right now, give us a like. If you're on YouTube, give us a like. And stay tuned for our upcoming events. We do them every week, every couple of weeks. Always top practitioners like this. Again, I'm Aaron. feel free to, I'm going to drop our email here, aaron@promotable.io. Feel free to reach out to us if anyone has any questions, or if anyone wants to learn more about classes or what have you, and we'll take it from there. With that, stay tuned for next time, and thanks again for coming, everyone.